I hope everyone's doing well. I'm Mr. Ish. Thank you for joining me for this interesting derivative rate of change word problem provided to me by a particular viewer from their textbook. Let's read it. We have a balloon which is rising at a constant speed of 5 feet per second. There's a cyclist going horizontally, riding at a constant speed of 15 feet per second. That cyclist passes under the balloon when it is 40 feet above him. How fast is the distance between the two? The cyclist and the balloon increasing 3 seconds later. Let's highlight. The balloon is rising at a constant speed of 5 feet per second. The cyclist is going at a speed of 15 feet per second. At time t equals 0, there's a 45 feet height difference between the two. What is the rate of change of the distance between the two 3 seconds later? You have to picture this and it will make sense. You have here at time t equals 0 a certain cyclist going in this direction, and you have a certain balloon going upwards, but the distance initially is 45 feet between the two. 3 seconds later, how much distance has been covered? If you know the cyclist is going at 15, 3 seconds later it's covered 45 feet in total distance. But in that same time, 3 seconds, the balloon which is going at 5 feet, it has covered an additional distance of 15 feet. Now when you're looking at these two, you have a 45 plus 15, you have a 60. If you bring everything here in terms of a right triangle, you have here a 60 feet in terms of the ground where the cyclist is and where the balloon is 3 seconds later, and you have a 45 feet distance covered. If you do a square plus b square is equal to c square, you can easily determine that 60 square plus 45 square, the square root, this will be 75. This right here represents the distance between the cyclist, which is right here, and the balloon, which is right here, 75 feet. But what is the question? The question is, what is the rate of change of that distance, the hypotenuse? That is what we're determining. If you don't determine these items from the get-go, you cannot solve this problem. But we have everything we need now to actually solve the problem. What is our basic equation? It's a square plus b square is equal to c square. When we apply the rate of change with respect to time and the derivative of these variables, you have a 2a, and the rate of change of the a variable with respect to time plus 2b, and the rate of change of the b variable with respect to time is equal to 2c, and the rate of change of the c variable with respect to time. What am I determining from right here? I'm determining this because I have to find the rate of change of the distance between the two 3 seconds later. The balloon being up here and the cyclist being here, we're looking at the rate of change of that hypotenuse. We have all of these values except for this. If you want, you can literally divide everything by 2 and get rid of the 2's. You could just divide everything by 2 and it wouldn't make any difference. A dA or dt plus b dB or dt is equal to c dC or dt. I have these dimensions. Let a be my horizontal dimension, b be my vertical dimension. A over here is equal to 45, b is equal to 60, c is equal to 75. I know my rate of change is the rate of change of the cyclist, which is 15. dA over dt is equal to 15 feet per second. The rate of change of the balloon rising is dB or dt, and that is equal to 5. We just plug in these values and we solve for that unknown. I have a 45 times its rate of change, which is a 15. Then I have a b, which is a 60 times the rate of change of the balloon's height, which is a 5, is equal to c, which is 75 times this variable, which I'll just call here an x. I'm solving for x. And let's calculate this, and it's easy. Remember, my x is a rate of change variable. I will do 45 times 15 plus 60 times 5. I have 975. I'll divide that by 75. Divided by 75. And I'm getting here 13. What does this answer mean? I'm getting over here x, which is equal to my rate of change of the distance between the two. The hypotenuse is equal to 13 feet per second. And this right here is my answer, and it will be correct. How fast is the distance between the cyclist and the balloon increasing 3 seconds later? Your answer is 13 feet per second at that particular instant in time. This dimension, the hypotenuse, will be changing at a rate of 13 feet per second, and it will be correct. And that brings us here to the end of this video. Thank you for watching.